Purpose of this short video is to provide an overview of the Asset 55 construction completion solution, which is joined to 3D models to improve visualizations. So Asset 55 are an owner-focused technology company, and we want to support owners through increasing visibility, awareness, predictability of project outcomes, particularly in the construction and completion space. So one of the areas that we focus on is a process called completions enablement, and part of this is because there is a gap in the industry, particularly in process thinking and technology. Many projects as they enter the last 30% experience significant problems, and this leads to delays, which largely increases or significantly increases cost for client organisations. So our completions enablement process is really focused at capitalising on a lot of activities that fall in that last 30% much earlier in the cycle. And what that does is it drives a quality of build process because the inspection regime is further forward, and largely will support reducing the tail on schedules and improving the cost position for clients. So I'm just going to start off by talking about why completions enablement or completions driven approach is important. So we take a typical S-curve, around 65% complete of a project signifies a change, and this is from a bulk build process to a system completion process. So what statistics have shown in the last 5 or 10 years is that the last 25% of construction projects take up to 50% of the overall duration to finish, and the last 10% can take up to 25% of the overall duration. So we need to understand why this is. So in the bulk construction phase, there's often very front-end loaded progress weighting. Structural steel makes up a large part of that. Bulk pipe fabrication and spool installation is relatively easy. And these are all things that EPC contractors or fabricators are good at. Counter to this in the completions process, man hours are always underestimated. There's a lot of complexity in finishing in the right sequence. There's a balance in maintaining bulk progress whilst enabling a completion process. And there's also all the discovery work because completions happen so late. This is also the time when all the errors throughout construction are found. Some of this needs engineering and procurement involvement, and all leads to increasing the tail. So we believe the opportunity to reduce schedule is to bring activities forward that typically fall in this last 25-30% through a process of opportunity and constraint analysis. So when we do this, each of these milestones that we've highlighted here get pulled forward. There will be bulk opportunities post 65%, and all of this will drive reducing the tail and increasing schedule predictability and schedule certainty. It's all about capitalising on completions opportunities as early as possible. So how do we do this? Here's a simple string of sequenced activities in the piping discipline. And what we do is we look at it differently. From an analytics perspective, we want to measure what we call trigger points or interface points between different activities. So this could be 10 spools and a test pack. When the 10th one is installed, we want to drive the test pack inspection to get out there and capture what the activities might be. So when you can reduce the time lags in between these interface points and openly communicate it, you have the ability to create one, predictability, two, look at KPIs in a different way, and third, which is the ultimate goal, is to reduce overall schedules. It's the same for an E&I perspective. Typically you have good control of major equipment status inside of rooms, but it's really about focusing on getting the trays and the right trays in, which will enable your cable pulling campaign, and linking this then back to which devices need to be installed when to drive your termination and your loop regime. So when you do each of these, you can communicate better, you can drive the behaviour of your contractor better, and you will save time. So what is it we're looking at doing? So here's the the high level activities and roughly where they fall in a standard approach. Discovery work is something that hurts every single project, and normally it's identified too late, and that's because the inspection regime or the completions activities don't typically occur until the last kind of 30%. So there's many reasons: things not being finished, missing materials, engineering change, things being done out of sequence that drive this kind of discovery work or the activities associated with discovery. So when we can bring these activities further forward, we naturally drive the inspection regime earlier, which means systemic issues don't become systemic because they can be identified early, work with contractors to change it so the volume of these significantly is reduced by the time we get into this back-end scope. And through managing all of this as well, we'll reduce schedule pressure, we'll reduce back-end burden of labour resource, which actually will improve safety outcomes. So that's just an introduction into why completions driven approach is important, how it can be achieved, and what really the focus areas are. So I just want to touch on workplace planning. Workplace planning has had a lot of attention over the last 5 or 10 years, and particularly in conjunction with a process called advanced work packaging. So, we see this as two different elements. Workplace planning is really about optimizing plans and creating alignment, and the advanced work packaging is then tying all the relevant deliverables together that the guy at the coalface needs, documents, materials, etc., to be able to do the work. So, from an EPC or a contractor's perspective, they have a different need and driver. Whilst there is visual planning, they also want to know, are the documents available? Are they IFC? Are they in my document management system? Are the materials available? Have they been ordered? Is it company supplied? What is the status of them and where are they? And what all the different indirects associated with a piece of scope? Do I need scaffolding? Do I need a crane to execute the work, etc.? And what happens is all of this is then pulled together into logical groups of about 1,000 hours for a work package. And then each of these are put together into a sequence to largely optimize a plan. One of the drawbacks is the technologies or the tools that are available to drive this process, like Bentley ConstructSim or Smart Plant construction from Intergraph, aren't really scalable. So on smaller scale projects, less than maybe $500 million or maybe $1 billion, it's really cost prohibitive to use these tools. So we want to explain this from an owner's perspective. They really have different drivers and potentially a different need from the tools. So whilst the owner still wants the ability to potentially visually plan the work, why they want to do it is different. It's about gaining internal alignment within their own team or with the external stakeholders that don't really constitute the construction contractors. They can work out what the optimized sequence is and how this should be grouped, and this then enables the challenging of the contractor's schedule. And thirdly, a completion strategy can also be tied into this planning process. A lot of the time now the commissioning and startup is being driven by the owner. So a lot of this information can be pulled through, which will largely drive how you can make a contractor behave and work. So it's really all about generating the possibility to influence outcomes. Whilst you want to plan for the best, you need to be prepared for the worst. So if intervention is required, you need to have everything associated with that intervention to then enable the next contractor or somebody else is being brought on or driving the change enabled from one place. So this is just to describe the subtle differences between the owner and the EPC needs, and our solutions are much more focused at the owner and scalable in terms of not being cost prohibitive from a small scale, smaller size project. So we're now going to focus on the model viewer element, the analytics for opportunity constraint analysis and enabling completions are stored within the construction and completions module. We're going to show you how the two of these interplay. So like with any cloud-based solution, there's the security protocols to enable a user to log in, and dependent on the user will ultimately give different access rights. So once in, it will tell you who you are. So this is me, Daniel, logged in. And it will also then identify what projects I have available to me. So these are two prototype demo projects. So I can select which project, and then within the project, it's going to tell me what type of models I can open up. So in each of the cases we're going to show you, it's the same model, but the opening it in a different way largely affects the way the user can interact with that model. So we have construction and completion, which is kind of your standard view of the world, opportunities and constraints. So this is now about the enablement piece. And then we have a work package view. So anything that's been grouped into work packages will then be viewed differently. So we have the reference, we have the different project types, and really it's about the way users interact. So here we can see we're part of the Gorgon project. It's construction and completion, so it tells you where you are. The selection tree down the left has been created based on a system grouping. So we want to use this from a completions perspective. Down the bottom here, the area called tags. This is where all the detailed components reside. They can be added to work packs, they can be selected and filtered, and the visual representation made to match. Up here we can minimize a lot of the data so we can interact with the model in a bigger way if we need to, and this can simply be opened up. So what we've now done here in system 62C03, we've dropped down into selecting a subsystem, which is the -00 equivalent, And here on the right hand side, everything else has been grayed out and everything associated with that subsystem has been selected. So to view the components down below, you can choose, how many of these you want to select in a given space. So this one here, we've opened it up to 25 entries, and here you can see down the bottom there's 156 entries. All the different attribute associated data can be scrolled across to the right, and there's also the search functionality. If the volume of tags is large and some of the items are known, you can use the search functionality. So here's the next visual. So instead of being at the system level, we're now down at a level. So this is a test pack 47 within that subsystem, and the model visual automatically zooms in and focuses in just on that individual scope. What we can also do is use the search functionality here, and we're going to search for just test pack 44 or search on 0044. So anything across the attributes that has 0044 will be pulled in, but this is just isolated everything associated with the 44 test pack. So now we're going to look at the next different interaction. So this model type now that has been opened up is the opportunities and constraints. So here the selection tree now changes, and it's categorized by different opportunity and constraint types. So under opportunities we have things that are ready for test, available for installation, ready for walk down, constraints, one spool balance, etc. So these can be customizable to the project type and what the owner wants to drive. So here we're going to look at an opportunity. This one is a test pack ready for walk down. It tells us that it's test pack 39. Underneath it we can see all the different line elements, and on the right it grays out everything else and focuses straight in. So you can see here it says all a 2-inch large test pack that covers the majority of the module. So down the bottom we can now get all the different isometric data associated with it, anything else from all the other attributes, and what we want to do is create the ability to export this information and potentially print out some of the drawings if need be. So the process enables us to do that very quickly and export the information. So now we're going to look at a constraint type. So this is a constraint, and the analysis has spat out that this is a test pack that has X number of spools, but it only has one spool that isn't reported as being installed. So within test pack 12, it focuses in on the one individual line and takes us straight to it to drive the superintendent to an area where, if he can complete the spool in that area, largely there'll be a test pack available for walk down, and the constraint will move, and it will now be flagged into an opportunity, which is the test pack will be ready for walk down. So here's another constraint type. It's a flange management or a joint that needs torquing. It identifies that the joint is actually part of the valve, and it's focused to straight in here on the valve, so the work can go and be completed. An extra element of functionality in here is a dimensional or a box volume. So let's assume that we're getting close to the end of a project, and some of this needs to be either taken out for ship loose, or there's an element where it needs to be taken out. Procurement can use the tool at the same time to identify what is the box volume and optimize containment for shipping. So this is now the third view of the same module. This is a work pack view. Largely again, you can see that the selection tree has now changed by different work pack types. So what we're looking at here is a transition work pack. It will group it by system level, so system 15A03, and this is what we've selected here. So what we might say is, why would this subsystem fall under this system? That doesn't necessarily make sense. As you can see on the right hand side, we have the model visual of where this transitional scope is. So let's now look at the data in a bit more detail. So here it will tell us what the work pack number has been called, Q204. It's a transition pack, and you can see here it's been flagged across 2 systems. So when we look at the tag associated data here, we can see that while the majority of it is in 12A03, there's also one line that crosses into 15A03. So it's obviously on a system boundary, so that transitional scope will be flagged against both subsystems as the work will need to be completed prior to completing those subsystems. So now we're going to look at a different project, because the interaction on this one was slightly different. So you can see up here we've opened a different project. The standard view in this case, construction and completions, is different to the one we viewed previously. So now instead of a systems-based tree, the configuration here is different, and this is because the module here needed to be seen as pre-assemblies, PAU A, B and C. So what this is showing is the standard view is completely customizable to the user or the project. So what this now does is we can select at the highest level PAUA, and it will identify everything that has been tagged to be associated with PAUA. What we can then do is within it we can use the isolate button, which will then remove everything else that's grayed out, which will allow a much greater level of interaction, without the user needing to scan through different areas of the facility where there's no interest. What we can then do is drill down to a further level of detail. So this is now still within PAUA, but we've just isolated everything that's either flagged as a cable tray, a device, an equipment, or a junction box. And the model visual is here. So in both of these examples, we haven't pulled in status because that data hasn't been made available. But with status, this can be pulled in on a daily or weekly basis. We could use our progressive inspection module, which is to capture status through using this solution on iPads or even your mobile phone, to pull different statuses back in, which then largely will drive different opportunities for visualizations for the owner. Thank you very much indeed. For any further information, please contact myself, Daniel Kalan, or Mike Rudd at the following email addresses, and we look forward to catching up with you again soon. Thank you very much.